Here I have come again with a new concept regarding the volume of solids. But before that, let's recall the formulae for different volume of solids which we have learned in our earlier classes. So let's start with the formulae. So first of all, let's start with volume of the sphere. So the volume of the sphere is given by 4 by 3 pi r cube, where r is the radius of the sphere. Then the volume of the hemisphere is given by 2 by 3 pi r cube, where r is the radius of the hemisphere. We see that the volume of hemisphere is just half that of the volume of the sphere. Third one is volume of cylinder. It is given by pi r square h, where r is the radius of the base of the cylinder and h is the height of the cylinder. The last one is volume of the cone. The volume of the cone is given by 1 by 3 pi r square h, where r is the radius of the cone and h is the height of the cone. So we must remember this formula in order to solve today's numericals. So let's proceed further. Today we are going to find out the volume of the combinational solids. It means just basically means that we have to find the volume of the combination of two or more solids. But before that, we must keep one thing in mind, that volume of two solids or volume of combinational solid is equal to the sum of the volume of the constituents. So keeping this thing in mind, let's solve today's numericals. So students, this is question number 1. So here is a toy which is given, which is a combination of cone and a hemisphere. So in this question, first we have to find the volume of the solid. So for that, we see that this is a combinational solid. So we will first find the volume of the cone and then the volume of the hemisphere, and then we will add these two volumes to get the final answer. So let's proceed. So this is the cone. We know that the volume of the cone is given by 1 by 3 pi r square h. So we see that here the radius of the cone is given by 1 centimeter and the height is given by 1 centimeter. So we will keep the answer in terms of pi only. So volume of cone comes out to be pi by 3. Now let's find out the volume of the hemisphere. So we know that the volume of hemisphere is given by 1 by 3 pi r cube. Sorry, the volume of hemisphere is given by 2 by 3 pi r cube. So the total volume of the solid is given by volume of the cone plus volume of the hemisphere. The total volume is equal to pi by 3 plus 2 pi by 3. So you see that the answer comes out to be pi. So let's move on to the next example. So this is a container containing some gulab jamuns. We see that it is given in the question that one gulab jamun contains 30% of the sugar syrup, and we have to find that the sugar syrup that will be contained in 45 gulab jamuns. And this is the diagram of the gulab jamun that is given. Its total height is given by 5 centimeter and the total diameter is given by 2.8 centimeter. You can see that from the diagram that this is a combinational solid which consists of cylindrical part and two hemispherical parts. So how will you approach this question? So first of all, we have to find the volume of one gulab jamun. So let's do that first. So we know that the volume of the gulab jamun can be found out by adding the volume of the cylindrical part and the volume of the hemispheres. So volume of the cylinder, we know that is given by pi r square h. And the volume of the hemisphere is given by 2 by 3 pi r cube. And since there are two hemispherical parts, you can see from the diagram, so we will multiply this formula by 2. So it will become 4 by 3 pi r cube. So the volume of the total solid for the gulab jamun is given by pi r square h plus 4 by 3 pi r cube. Now let's get out common something. We see that pi comes out to be common. Now we see that the radius of the cylindrical part and the hemispherical part is same, which is given by 2.8 divided by 2, that is 1.4. So here is r square, here is r cube, so r square can be taken out common. So in the bracket we keep h, that is the height of the total, sorry, h will be the height of the cylindrical part only. This 4 by 3 r. So let's put out the values first. So in terms of pi we write 22 by 7 multiplied by r is 1.4. Now what will be the height of the cylindrical part? Since we know that the total height is given by 5 centimeter and the radius of these radius of each hemispherical part is 1.4. So if you multiply 1.4 by 2, it comes out to be 2.8. So we have to subtract 2.8 from 5 in order to get the total height of the cylindrical part. So cylindrical part has the radius 2.2 centimeter. So just put this value in our formula. Again we see the radius of the solid given by 1.4. So if you calculate this, you will find that the answer comes out to be 25 centimeter cube. Now it was given in the question earlier that one gulab jamun contains 30% of its volume. So since we have 25 centimeter cube is the volume of one gulab jamun, then the sugar syrup that will be contained in this gulab jamun will be 30% of this volume. So you see that the volume of the sugar content in one gulab jamun comes out to be 75 centimeter cube. So since in the question it was given that there are 45 such gulab jamuns, so the total sugar syrup that will be contained in 45 gulab jamuns can be found out by multiplying the 75 centimeter cube by 45. So let's multiply. So here was a mistake first, you can see that I have forgot the decimal part here. So the answer will be 7.5. So the total sugar content in 45 gulab jamuns comes out to be 337.5 centimeter cube. So let's move on to the next question. So there is another question you can see here. So this is the pen stand which we have taken, and the pen stand has some. This is the form of a cuboid. The pen stand is in the form of a cuboid, and it is used to hold some pens. And now in this pen stand, we have made some conical depressions, which means that some amount of wood has been carved out in order to make space for the pens. So we see that the total amount of wood that will be used in making this pen stand will be less than total amount of wood which will be used in making total cuboidal box. So here the dimension of the cuboid is given. It means that these are the dimensions before making the conical depressions, and this is the radius of each depression. Means this depressions is in the size shape of a cone. So this cone must have some height, and this cone must have some radius of the base. So the radius of each base is given by 0.5 centimeter. And what will be the depth or the height of the depression? This height is given by 1.4 centimeter. So in this question we have to find out the total amount of wood which is used in making this pen stand. So let's first find out the total volume of the cuboid. Then we will find out the total volume of each depression, and then we have to subtract both to get our final answer. So how will you find out this question? First of all, we have to find out the volume of the cuboid. We know that the volume of the cuboid is given by length into breadth into height. Here length, breadth and height are given in the question, but it is found out by 15 into 10 into 3.5. So this decimal is considered by 10. So this is decimal is 15 multiplied by 35. Okay. So let's multiply this to. So the answer comes out to be 525 centimeter cube. Okay. Now, since there are 4 conical depressions, so the total volume of the total depressions can be found out by multiplying the volume of one conical depression by 4. So we know that these are the shape of a conical shape. So we will first find out the volume of the cone. So we know that volume of the cone given by 1 by 3 pi r square h, and this has to be multiplied by 4 because there are 4 conical depressions. So answer given by 1 by 3, 22 by 7. Radius of each depression is given by 0.15, so it will be 0.5. If you use the decimal, it will be 5 by 10. And the height of each depression is given by 1.4. And it will be multiplied by 4. So see that, that will get 10, that will get 10. Here 7 over 7 and 7 to the 40. Here 2 on the 2 and 0.1. Here 2 on the 2 and 2 on the 2. So you see that in the numerator we have 11 multiplied by 0.1 multiplied by 4, and in the denominator we have 3. Okay, so 11 4 is 44, and let's rub this. So 44, if we multiplied by 0.1, it comes out to be 44 multiplied by 1 by 10 is 4.4, and if 4.4 is divided by 3, we have 3 into 3 equals 12. So the answer comes out to be 1.46 centimeter cube. These are the total volumes. So we see that if we want to find out the total amount of wood that has been used in this pen stand, we have to subtract these two values. So the total amount of wood will be given by this 525 centimeter cube, which was the volume of the cuboid, and to subtract the volume of 1.46, which are the volume of the 4 conical depressions. So our answer comes out to be 523.54 centimeter cube. So let's move on to the next question. So this is another question which is based on the concept of combinational solid. We see that this is a spherical vessel which has a diameter which is given by 8.5 centimeter, and it has a cylindrical neck whose height is given by 8 centimeter, and the diameter of this base of the cylinder is given by 2 centimeter. So we need to find the amount of liquid or water which will be holded by this spherical vessel. So before that we must keep one thing in mind, that whenever we have to find the volume of the two combinational solid, as I have told earlier in the beginning of the lecture, that the total volume of the combinational solid will be given by the sum of the two individual constituents of the solid. It means that in order to find the total volume of the combinational solid, you have to first find the volume of the cylinder, then you have to find the volume of the spherical shape, and then we have to add these two in order to get the amount of water which will be provided by the result. So let's find the volume of cylinder first. You know that the volume of the cylinder, it is given by pi r square h. Let's keep pi as it is. Since the diameter of the base is 2 cm, so the radius of the cylinder will be given by 1 cm, and the height is given by 8. So the answer will be 8 pi. Now what will be the volume of the spherical shape? We know that the volume of spherical shape is given by 4 by 3 pi r cube. Keep pi as it is. Since we see that the diameter of the spherical vessel is 8.5 cm, so radius will be given by 8.5 by 2. So the total volume of this combinational solid for the spherical vessel it is given by 8 pi plus 4 by 3 pi and 8.5 by 2 whole cube. So from this we can see that we can take pi common. There will be 4 by 3, 8.2 pi by 8.5 whole cube, and here will be 8 plus 8. See that 2 gets cancelled easily. There it will be 6, it will be plus 8. Now we have to find the cube of 8.5. So you see that 8.5 cube is given by, let's find it out. So the square of 8.5 is given by 72.25. So the cube of 8.5 comes out to be 614.25. Let's take up to 2 decimal places only. Now let's divide 614.12 divided by 6. So here you see that answer comes out to be 102.35. You have to add 8 to it. If we add 8 here, we get 110.35. Now use this formula. In place of pi, we will use 22 by 7. I just use 3.14. Now let's multiply 114 by 110.35. The answer comes out to be 346.49. So we see that in order, so you see that the volume of the spherical vessel comes out to be 346.49. So in this way we will solve many more questions. Whenever we have question which is based on the concept of combinational solid, we will find the volume of each constituent and we will add this data in order to find the final answer. So that's all. So I hope you enjoyed today's lesson, and please like, share and subscribe for more amazing content. Till then, stay tuned. So that's all. So I hope you enjoyed today's class, and for more amazing content, please like, share and subscribe our YouTube channel Easy Maths for you. Till then, stay tuned.